All right, well, we're going to be looking at prime factorization today. And so with this, we're going to be kind of reviewing what the different divisibility rules are. We're going to look at factor pairs, finding prime factorization, and then finding a number that has been written in prime factorization, and then trying to find the perfect square that is a factor of a number. So those are our various topics. So let's go ahead and dive in right about now. Okay, so when it tells us to use the divisibility rules to determine whether the number is divisible by 2, 3, 5, 6, and 10, let's just discuss what the different divisibility rules are. So for a number to be divisible by 2, you can, the last digit of the number is an even number. So if it ends in a 0, 2, 4, 6, or 8, it's any number. Any number is divisible by 2. Now for the number 3, for it to be divisible by 3, let's say that I have the number 42. With 42, if I add the digits 4 plus 2, I get 6. 6 is divisible by 3, therefore 42 is divisible by 3. What if I have 111? If I add 1 plus 1 plus 1, I get 3. 3 is divisible by 3, therefore 111 is divisible by 3. That's the rule for 3. Now for 5, if it ends in a 5 or a 0, it's divisible by 5. 6, if you can divide the number by 2 and 3, it's divisible by 6. So basically, if it's an even number, if it ends with an even number, and if you add the digits together and divide by 3 and it works, then that number can be divided by 6. And then for 10, it must end in a 0. So let's take a look at 2,322. So easily I can tell it's divisible by 2 because it ends in an even number. Now for 3, if I take 2 plus 3, I get 5. And if I do 2 plus 2, I get 4. If I add 4 and 5 together, I get 9. You can divide 9 by 3, therefore you can divide this by 3. It ends in a 2, so you can't divide it by 5. It is divisible by 2 and by 3, therefore it's divisible by 6. And you cannot divide it by 10 because it does not end in a 0. So we know this is divisible by 2, 3, and 6. Let's go ahead and look at number 2. Is this divisible by 2? Well, it ends in a 0. 0 is an even number, therefore it is. How about, is it divisible by 3? Well, I take 4 plus 1 plus 4, which is 9. I'm sorry, 4 plus 1 is 5 plus 4 is 9. You can divide 9 by 3, so yeah, it's divisible by 3. Is it divisible by 5? It has to end in a 0 or a 5, which it does, so yes, 5. And then for 6, it is divisible by 2 and 3, therefore it's divisible by 6. And finally, it ends in a 0, therefore it's divisible by 10. So here are the numbers you can divide 4,140 by. All right, let's go ahead and move on to our next section. All right, so in this section, we're looking at listing the factor pairs. So a factor pair would be 2 whole numbers you can multiply to get our number that we're given. So 40, we can always start with the really easy one. 1 times itself. Then I have to think, can I divide it by 2? Well, it's even, so yes, so 2 times 20. Can I divide that by 3? Nope. 4? Yep. So 4 times 10. Can I divide that by 5? Yep. 5 times 8. The better you know your factors in division, the easier this is. Okay, well, 6, no, because it's 36. 7 times 7 is 49. We are all out of options because once that first number is bigger than the second number, we've already passed all of them. So these are our factor pairs. Let's try for number 4. We're going to try, again, 1 times 33 Can't do 2. Let's try 3 times 11. 4 times 4, nope, that's 16. Or 4, no. 5, nope, it doesn't end in a 5 or 0. 6 times 6 is 36, so we've now passed it. So these are the only factor pairs we can come up with. All right, let's go ahead and check out our next section. For here, it tells us to write the prime factorization of the number. So I'm going to take the 42. And one way you can do it is you can do a factor tree. And with this, I'm going to think, what two numbers can I multiply to get 42? Well, I can get a 6 and I can get a 7. 6 times 7 is 42. I stop once all of the factors are prime numbers, hence the name prime factorization. So 6 becomes 2 times 3, and then bring down that 7. And I'm all done. They're all prime, and they're all different, so I can just leave it as 2 times 3 times 7. Now for 36, another way you could do this is I could take the 36, and I can, I'll do it this way. Take the 36, and I can divide by, I would divide by prime numbers. So like I can divide by 2. 36 divided by 2 is 18. I can divide this again by 2, and I get 9. I can divide this by 3, and I get 3, and I'm all done. So 2 times 2 is 2 squared, times 3 times 3, 3 squared. Now, the method you choose is up to you. I would have done for 36, I probably would have used the factor tree because it seems to be easier because I know 6 times 6. But it's really up to you. The bigger the number is, I tend to like using the steps, that second one, just because I can continue dividing by small numbers. All right, let's go ahead and check out our next section. All right, so in this section, the directions say, find the number represented by the prime factorization. So we're given the prime factorization, all we have to do is multiply. So I have 2 to the third power, which is 2 times 2, 4 times 2 is 8, times 5 times 5 is 25, times 11. If I have 8 quarters, I have 200, times 11. And then I can just do 200 times 11, and I get 200, and then 200, so I get 2,200. So this is 2,200. That would be the number represented by 2 to the third power times 5 to the second power times 11. So look at number 8. Here I have 2 to the fourth power, which is 16, times 3 to the third power, which is 27. I'm going to multiply this, so I'm going to do 27 times 16. Now, if you have a calculator, you could use that. I know for my students on their test, they're going to be doing the whole test without a calculator, so they're going to have to do this by hand. So I'm going to do it by hand, but you know, if you have a calculator, feel free to use a calculator to help you. 6 times 7 is 42. Carry the 4. 6 times 2 is 12, plus 4 is 16. Bring my 0, and 1 times 27 is 27. I have a 2. 6 plus 7 is 13. Carry my 1. 1 plus 1 is 2, plus 2 is 4. So 432. So I have 432. All right, take a look at our last section. All right, this last section could be a little confusing. I'm going to try with a real easy one first to show you, okay? We're going to look at the number 20. And to find the greatest perfect square that is a factor, I'm going to do the prime factorization. So 20 can be factored down to 4 times 5, and then I have 2 times 2 times 5. So I'm going to look at, out of my prime factorization, do I have any pairs? Yeah, I have 2 times 2, so that gets me 4. And so 4 is my greatest perfect square that is a factor. I'm going to give you another one just so you can see another example. What if I have if I have 80? So with 80, I can break this down to 8 times 10, and then this is 2 times 4 times 2 times 5, and then I have 2 times 2 times 2 times 2 times 5. Now, this I'm going to look at. I have 2 times 2 here, 2 times 2 here, which is really 4 times 4, which is 16. So 16 would be the greatest perfect square that is a factor, because 16 times 5 is 80. Hopefully this is making some sense. Now 378 is kind of a tough one. Let's look at how this works. So 378, I am going to, I'm actually going to erase this now if that's okay. I apologize. Erase this. You can always rewind if you want to see this again. I'm going to go ahead and look at this. I know I can take 378 and I can divide it by 2, right? Because it's an even number. So I take my 378, divided by 2, I get a 1. Bring down my 7, I get a 8. Bring my 16, bring down my 8, I have a 9. So I have 189. 1 plus 8 plus 9 is 18. 18, and this is another one. You can divide 18 by 9, and it is divisible. You get 2, right? So that tells me I can actually divide 189 by 9. So I'm going to take this, I'm going to go 2 times 9 by, let's find out. So I'll take the 189, can divide by 9. This goes in twice, get 18. Bring down my 9, goes in once. So times 21. Now it's easy, right? So I can do 2 times 3 times 3 times 3 times 7. So I'm going to look to see what a perfect square is. Remember, a perfect square is a product of a number times itself. So I have 3 times 3, which gives me 9. So 9 would be my perfect square. Okay, that's it. This one's a little bit longer. Hopefully you found it helpful. As always, make sure you like, you subscribe if you haven't already done so, and you click that bell so you can know when I have updated and added new videos. Okay, thank you very much. Have a great day.